Hi friends, in this video we are going to discuss about starters. So generally tell me the first question, why we are using starters? Option A, to start the motor. Option B, to control the high starting currents or to limit the high starting currents. Which are the following is correct answer? Option A, to start the motors. Option B, to limit high starting currents. So, starters are used to limit the high starting currents. Starters used to limit high starting currents. High starting currents. Starters are used to limit high starting currents. So generally, why we have to limit the starting current? Generally, in our induction machine, the starting current is around 5 to 7 times of the full load current. The starting current is 5 to 7 times of the full load current. Nothing but due to this high current, the machine may damages. That's why we have to control this high starting currents. That's why we are using starters. So generally, what is the formula? I is equals to V by Z in generally. I is equals to V by Z. Starting current is equals to simply V by Z. So how we can control the starting current? How we can control the starting current in our AC machine like an induction machine? In our induction machine, by controlling the supply voltage, we can control the starting current. In our induction machine, by controlling the supply voltage, we can control the starting current. Sir, this is okay. In induction machine, by controlling the supply voltage, we can control the starting current. What about DC machine? In DC machine, how we can control the starting currents? How we can control the starting current? In DC machines, by adding extra resistance. By adding extra resistance, we can control the starting current. By adding extra resistance, we can control the starting current in DC machines. Whereas in our induction machines, by controlling the supply voltage, we can control the starting current. Okay, this is simple about why we are using starters. And next one, how many types of starters are there in our induction machine? How many types of starters are there? Generally, you people already know. The first one is direct online starting. Nothing but DOL starting method. Direct online starting method. DOL starting method. This is the first one. And second one is stator resistance control method or stator resistance starter. This is the second method. And third one is auto transformer starter. Third one is auto transformer starter. And fourth one is star delta starter. And fourth one is star delta starter. And fifth one is rotor resistance control. Rotor resistance control starter. Rotor resistance control starter. Finally, we have 5 types of starters for induction machine. Let's discuss each and every one. The first one, direct online starting. Check the heading. First one, direct online starting. Let's see what are the different types here. Let's see each and every one. Right. First one, direct online starting. DOL starting method. Direct online starting method. Nothing but there is no any starters we are using actually. Here, actually, the induction motor directly connected to the supply mains. Directly connected to the supply mains. My induction motor directly connected to the supply mains. There is no any starters. Directly connected to the mains. Direct online starting. This is also used. Generally, this method of starting used for low rating machines, low diameter machines. This is used for low rating machines like a less than 1.5 kilowatts. Low rating machines, nothing but less than 1.5 kilowatts rating machines. Generally, we are using as well as this is generally used for low diameter machines, because it gets started quickly. Like that. For low diameter machines and for low rating machines, generally we are using the direct online starting. In this machine, the starting current is simply IST only. And in this machine, the voltage V only. There is no change in voltage, there is no change in current. So what is IST here? Simply IST is equals to V by Z only. There is no control of voltage. Directly connected to the supply mains. This is simply the direct online starting. And here very important, the ratio of starting torque to the full load torque. They are asking problems also this one. They asked already many times in GATE exam also. The ratio between starting torque to the full load torque. I already given you the full load torque formula. Full load torque is equals to 3 into I2 dash square into R2 dash by S into omega. 3 into I2 dash square into R2 dash by S into omega is the full load torque formula. Generally, my assumption, if K is equals to 1, what is R2 dash? R2 dash is equals to R2 and I2 dash is equals to I2. If K is equals to 1, actually what is formula for R2 dash? R2 dash is equals to R2 by K square. If K is equals to 1, R2 dash is equals to R2, I2 dash is equals to I2, and I'm taking, this is full load torque, right? And this is full load current. This is taken as full load current. Now tell me, what is full load torque formula? Full load torque is equals to 3 into I full load current whole square into R2 by omega into S. S nothing but the full load slip. The full load current. Yeah, this is my full load torque. Now I want starting torque formula. Similarly, write down what is the starting torque formula? 3 into, for this is full load torque, full load current. For starting torque, IST, starting current whole square into, there is no change of resistance. We already saw in the rotor analysis, the rotor resistance is same for standstill condition and running condition, and divided by omega into, omega is also same. And what is slip at starting condition? At starting condition, slip is 1. Now compare these two. Omega gets cancelled out, and 3 gets cancelled out, and R2 gets cancelled out. The very, very important formula, starting torque to the full load torque is equals to, this S full load comes into numerator, S full load into I starting to the I full load whole square. This is the formula for starting torque to the full load torque. Starting torque to the full load torque is equals to slip at full load into starting current by full load current whole square. This is important formula. There are many questions in GATE exam also based on this formula. Right, sir? This is about generally the starting torque to the full load torque and direct online starting. Okay, this is about first method, direct online starting. Okay, now second method. What is the second starter? The stator resistance control. Stator resistance control starter. Right? What we are doing here, see here, this is the actually supply mains. From supply mains, this is connected to some rheostat. Actually. Now here I am taking the tapping points and which is connected to our induction machine or our induction motor. This is stator resistance control. This is the resistance which we can variable. Here we can vary the value. Based on the tapping, this tapping may be 50%, 60%, 80% like that. Nothing but, for example, X percent. If it is placed at 100%, 100% will transfer to the motor. If you are taking 50%, just 50% of voltage given to the motor. Like that, now the voltage comes to the motor is just X times of the V, where X is the tapping percentage, 50%, 60%, 80% like that. Now the current is same, the current is IST, for example. Take here, generally we know the starting current is equals to actually V by Z, but actually in our method the voltage is X times of the V. So the starting current in stator resistance control, the starting current in stator resistance control is equals to X into V by Z. V by Z nothing but the starting current in DOL starting. So the starting current in stator resistance control. Stator resistance control is equals to X times of the starting current in DOL starting method. Based on the percentage, we can reduce starting current. Starting current reduces, and also we have a formula. Starting torque to the full load torque is equals to slipped full load into starting current by full load current whole square. What is the starting current in this method? The starting current is X times of the actual starting current. X times of the actual starting current. So what is the final value? This value, starting torque to the full load torque is equals to starting torque to the, I'm writing here, starting torque to the full load torque is equals to X square. Take common, X square into slipped full load into IST by I full load whole square. Nothing but some factor is there, X square. So what you observe? The starting torque in this method nothing but stator resistance control method. The starting torque in stator resistance control method is equals to X square times of the starting torque in DOL starting. This is also very important. The starting torque in this method is equals to X square times of the starting torque in DOL starting. Current reduced by X times, torque reduced by X square times. In this method, current reduced by X times, but torque reduced by X square times, because generally torque directly proportional to I square. Already current reduced by X times, that's why torque reduced by X square times. This is the stator resistance control starter. Okay, next time, third one, auto transformer starter. Auto transformer starter. Let's see here. Take a auto transformer, for example. This is my primary of the auto transformer. This is my primary of the auto transformer, where the current is I, where the voltage is, the phase voltage is V. The current is I and phase voltage is V. For example, here I'm taking the secondary of the auto transformer, like this. This is primary and this is secondary. Here, the secondary of the auto transformer tapped up to some X tapping into V. Here the auto transformer tapped up to X%. X nothing but the tapping percentage, for example, 50%, 60%, 70%, 80%, 90%, like that. Like that, here the transformer is tapped up, and now this is connected to a induction motor. This is connected to a induction motor. So voltage reduced by X times, and current value is X times of the IST in DOL starting. This is the IST in auto transformer starter. This is the X times of the IST in DOL starter. Now tell me, what is the voltage and current? Nothing but what is the power rating of primary? Nothing but is the V into I starting in auto transformer is equals to V X times of the V, and current X times of the IST in DOL starting. Here V gets cancelled. Next, the starting current in auto transformer starter is equals to X square times of the starting current in DOL starting. X square times of the starting current in DOL starting. This is very important. Nothing but here the current taken is X square times of the IST in DOL. Nothing but the current taken by the auto transformer, current taken by auto transformer is X square times of the starting current in DOL, but the current taken by the induction motor, the current taken by the induction motor is X times of the starting current in DOL. X times of the starting current in DOL. The current taken by the auto transformer is X square times. The current taken by the induction motor is X times. Right? Let's see here. What is the torque equation? The starting torque to the full load torque is equals to S full load into starting current by full load current. What is the starting current taken by the motor? The starting current taken by the motor is X times of the IST by I full load whole square. Nothing but the starting torque to the full load torque is equals to X square times of slipped full load into IST by I full load whole square. Again X square times. Nothing but the starting torque in auto transformer starter is equals to X square times of the starting torque in DOL starting method. The starting torque in auto transformer starter is equals to X square times of the starting torque in DOL starting. The torque controlled by X square times, but see here the current controlled by X square times. For auto transformer, the current given to the motor is X times. Are you getting or not? The current taken by the auto transformer is X square times. The current taken by the induction motor is X times. And torque in auto transformer starter is equals to X square times of the torque in DOL starting. X square times of the torque in DOL starting. This is also very important. Let's see here. In this method, generally power factor is less. In this method, generally the power factor is less and cost is more because of auto transformer. Cost is more and power factor is less because of auto transformer. The cost is more. These are generally the disadvantages, but generally these are used for high starting current, nothing but high starting time applications. Generally this is used for high starting time applications. high starting time applications. And also in this method, the current controlled by x square times. Current controlled by current controlled current controlled by x square times. That's why this is of course good method. High starting time this is used for, and x square times current controlled x square times, and here power factor is less and cost is high due to auto transformer. Due to auto transformer, current is cost is high and the power factor is less. This is about generally the auto transformer structure. Once see.